Hi everyone, this is just a quick video on doing linear regression in R. The data set I'm going to be using is called MT-CARS, which is right over here. And we're going to be trying to model miles per gallon as our response and other various variables as our predictors. So the most basic way to do it is to write the model as I have here on the first line. In the case for linear regression, we're going to be using the LM function. On the left-hand side of the squiggly is going to be our y value or our response, and on the right-hand side is always our predictor or our x value. Go ahead and run this, and we're going to get our intercept and our coefficient and our model, which is super helpful. We can also use this format, which I have right below, which is going to give us the exact same thing. R is a really smart language, and there's lots of ways to do everything. We can also make our models a little more complicated. So for instance, if we were interested in modeling miles per gallon with cylinders and I believe this is weight, we can go ahead and do that. So the formula would be miles per gallon is equal to cylinder plus weight, and there's our coefficients. We might also be interested in making a polynomial, so cylinders plus cylinder squared. We can do that using the poly function, which is just a little more concise. We can also do an interaction term, just how you normally would write it, cylinder times weight. And again, as I said earlier, R is a really smart language. When you do this, you can actually, R will actually fill in the gaps for you and put cylinder and weight in there, because in general, if you have an interaction term, you should always include the terms as separate values also. If you don't want to, you can use the colon, which will just do it for the single interaction term. But again, in general, you always do want the interaction term in the single values. Some features of the LM function: if we save our results, so in all these examples before I was running them but not saving them, but if we save them into fit, for example, we can run ANOVA, which will give us a nice ANOVA table of all of our values. We can use the summary function, which will give us, again, more useful information, 5-number summary, a summary of the coefficients, significance values, F statistics, R squared, etc. We can also utilize plot functions in R. So if we type plot fit, this will actually give us 4 separate plots that are super helpful. It's a little hard to see. I'll go ahead and zoom. There we go. And we'll see the next plot. And the next plot, and finally the 4th plot. These are all super helpful for when you go further into your statistical career. You're going to be needing to know all these plots, and it's really nice to get them really quickly. You can also plot your model directly just by using the exact same arguments that we had above, right in plot, and this is how you would get your model directly. And if we wanted to fit a line to this model, it's really easy. We use the abline function, which puts it straight in. And finally, we can also use predict. So if I had my model now and I wanted to predict values and maybe get confidence intervals for those predictions, in this case, I'm going to generate a random numbers called SIL. These are my random numbers that I want to use to predict. These random numbers always need to be your input numbers, and they need to be in the form of a data frame. But my first argument would be the fit object, which I defined up here. The second would be the input variables, and the third would be what I want. This is an optional argument, and if I run it, I now have the predicted value, the lower bound, and the upper bound.